And we're live. Hi, everyone. Thank you so much for joining us again for this week's on .NET Live. My name is Cecil Phillip, and today we're going to explore the world of Spark and ML.NET using F#. And I have my good friend here, Luis, who's going to tell us all about it. Now, if you've never been to the show before, if this is your first time, we stream all about .NET community, .NET projects. We're here every Thursday. So if this is your first time, thank you so much for joining us. We really appreciate it. And hopefully you join us again for our other shows. Now, Luis, why don't you go ahead and introduce yourself to folks really quick? Just let us know really quickly who you are and what exactly do you do.
Yeah, for sure. So I'm Luis, and I work for Microsoft Docs, and the areas that I focus on are specifically big data and machine learning. So I work in documentation for .NET for Apache Spark, which we're going to talk about today, as well as ML.NET and Azure Machine Learning. So really, that whole space of machine learning. So you could say that this talk really, it's sort of a culmination or like, an aggregate of basically all the stuff that I work on. So I'm super passionate about this stuff, and especially when I get to write some F# code, I'm always happy when I get to do that.
Nice. So before we really start diving into a lot of these topics, I'd love to hear how did you even get started learning about machine learning and diving into data exploration in F#? What was the thing inside of you that was oh, this is a really cool thing for me to check out?
Yeah, for sure. So it actually started. So I remember hearing about F# back in 2011, and at this time I still wasn't really sort of doing development sort of full time. I was actually in the financial industry prior to sort of jumping over here to tech. But I did hear about F# because in finance, right, at the time, F# was a language, and still is, a language that is used, right, and mainly because it's really good at processing data and analyzing data. But when I first tried to get into it, I was at the time, again, this was pre.NET Core, so no cross-platform, Windows only. You had to have Visual Studio, right? So it definitely felt like there was a bit of a barrier to entry, and it felt like one of those things where it was oh, I need to know all this math in order to sort of get started, right? This is only for math people. Fast forward, a few years, .NET Core, F# is out. At the time, I had started doing some work with Python and building machine learning models with Python, and that seemed to work okay, right? Because Python tends to be the dominant platform for the most part for machine learning and data type of applications. But I found myself lacking something in Python, and when I came over to working on .NET Core and C# and started working with ML.NET, I was man, it's really cool that you get to have the compiler and you have the safety of the compiler, and not only that, right, but with .NET Core, it was just super fast, right? It was very fast, very reliable, and performant. So I'm I like the succinctness of Python, but I also like the compiler. And for one way or another, I ended up coming to F#, and I was okay, well, I get the best of both there. I get super succinct code, easy to write, easy to understand, and at the same time, I have the power of the compiler helping me the entire way. So that's kind of my very windy sort of road to F#.
Nice. I totally agree with you. I do a little bit of Python too, in addition to some other languages. But one of the things that always keeps me grounded in .NET is the interoperability throughout the ecosystem for me is huge. And I'm not just talking about just the language, but the tooling from Visual Studio and VS Code and all the different extensions that you can use, all the other IDEs Writer and all the other ones that are out there, .NET Interactive. And now I could have a ton of different languages. I can write web, mobile, desktop, all kinds of other things. And I can kind of just be in the same place, in the same comfortable place with the same comfortable tools. And for me, that's a lot less for me to keep in my brain to be how do I configure this thing to get it to work?
Yeah, and the tooling, it just keeps getting better, right? You mentioned .NET Interactive, which is, especially for learning environments, it's a really great tool. But we're going to see here also, right? It really brings visuals and really brings data to life, right? If you're working in data. But that being said, though, a lot of folks tend to look at .NET Interactive oh, .NET Interactive is only for data scientists, right? But that's definitely not the case. Well, it's true that it's predominantly used within that industry. let's say that you were, working in some call center and you needed to sort of reproduce some sort of bug that was happening, right? You can easily just share these .NET Interactive notebooks, and somebody could just run it and really see, and step through, what issues led to, that bug. So there's definitely a lot of use cases, and it's really exciting to see, tooling like that sort of make its way into the .NET ecosystem.
Yeah, for sure. So I'm really excited to see like some of the things that you're going to show us, and I know the folks in our chat are definitely excited as well. Always in this part of the show, I always like to give a quick shout out to everyone that's here. I know we always have folks from all over the world that are joining us. I know we have some folks here from UK and from Africa, from South America. So again, wherever you are, definitely appreciate you being here. It might be early morning or late night or whatever the case is. Hopefully that you get some value about all the things that we're going to talk about today. Now, before we move forward, what I like to do is I want to share a few announcements just so that we could know what some of the cool things that are going on are. Now, the first one that I want to show, so happening on July 29th, so that's this month, we're going to have a .NET Conf event. This is going to be focused on F#. And if you're familiar with like the .NET Conf focus events, they're essentially like a free all-day streaming event where they talk about any particular topic. So again, we're going to be talking about F# for this one, and there'll be tons of great speakers and demos, and you'll see tons of great projects and things of that nature around F#. So if maybe you're F# curious, or maybe you've been writing things with F#, or just wondering what can I do with it and what are some of the capabilities, this is definitely a good conference for you to check out. And even though I don't have a link for this yet, the day after this, on July 30th, there's going to be another event that's going to be called Let's Learn.NET. And we do these Let's Learn.NET events every month, and this one is also going to be focused on F#. So July 29th, July 30th, you're going to have back-to-back F# things. So again, if you want to learn F#, you have no excuse now. There's tons of opportunity for you to come in and do that. Now, moving on to also another really recent event. Yesterday, they just announced .NET Core, .NET 6 Preview 6 is out. And this has tons of great updates and features to it as well. As you can see here, there's going to be x64 emulation in there, some updates to the new .NET workload tool that's going to be inside of the .NET CLI. Again, libraries for TLS support and tons of other great stuff. I'll make sure I share this document, this blog post inside of the chat. So if you want to take a look and see what are some of the cool things that they added to Preview 6 for .NET 6, you can go ahead and check those out. And another great project that had some updates just yesterday that Luis was telling me about was ML.NET recently just released version 1.6.0. And this has tons of great stuff in it too. As you can see here, now you can run ML.NET on ARM, which is really awesome. There's ARM64 support. There's support for Apple Silicon that's in there as well, which is really great for those of you that are lucky enough to have an Apple Silicon device. And then you can also run ML.NET in Blazor, and there's updates to the model builder. Again, tons of great stuff if you're someone that's going to be focusing on ML.NET. And like I said, like Luis is going to be talking to us about ML.NET just in a little bit. So if you've never heard about it before, or played around with it before, you're going to get a little bit of a sneak peek as to what are some of the things that it could do. And honestly, I always like to say, if you're interested in the project and you want to make sure that you know what's going on or you want to get involved, definitely head over to the GitHub repo. So that's going to be github.com/.net/machine learning. And you can check out the new release. You can see all of the different enhancements and features that were added to this release. And if you want to send the team some feedback, go ahead and use like the little issues section here at the top, and you can share them, any type of feedback that you have. Now, with that being said, and I always like to say this is no longer the Cecil show. This is not a Luis show. So now I'm going to let you take over and kind of, walk us through this world of Apache Spark, of ML.NET, of F#, and see how, well F# helps us play inside of this world.
Yeah, sure. Let's do it.
All right, so I'm going to bring up your screen really quick, and we can get the show on the road.
Yeah, awesome. Yeah, it's super exciting to see, sort of the developments around .NET 6 that are happening that you mentioned. Definitely, ARM support in large part was kind of due because of that, right? In ML.NET, and it's only going to get better, right? So it's super exciting. I know that's something that people people really have been asking for a while, especially Xamarin developers, right? So now that there's ARM support in ML.NET, that's something that should, that now they should be able to use ML.NET models instead of their mobile applications. But anyway, if you don't know what ML.NET is, you've been hearing about it, but if you don't know what it is, I can just share this sort of resource, and this is actually the long link, but if you go to .net/ML, it will bring you to this page here, which is really the landing page for ML.NET. And as the name says, it's an open source and cross-platform framework for machine learning. Now, what that means is that you can train custom machine learning models using the languages that you know and love, C#, F#. But you can also consume models from other frameworks such as TensorFlow. And if you have an ONNX model, you can also consume ONNX models, right? So there's an interoperability component where if you have, or you're working with folks who are using Python and the Python set of tools to build their machine learning models, using ML.NET, you're going to be able to sort of share those models and deploy them to your .NET applications. So you can definitely approach ML.NET from a code first standpoint, but there's also tooling like Model Builder that makes it super easy. It takes you through this like wizard-like experience. And we actually, I think about a month ago or 2 months ago, we were on here on the .NET show and kind of showed off this experience where you go through the tooling and all you really need to know is the type of problem that you want to solve. Give Model Builder your data, and just set it off to the races and let it train, and it will automatically train a model, or try to find the best model based on your data. So that's kind of how you can get started with ML.NET. In terms of .NET for Apache Spark, .NET for Apache Spark, what it is, it's bindings, .NET bindings for the Apache Spark engine. So if you're not familiar with Apache Spark, it's this sort of general purpose analytics engine that allows you to run workloads, across in distributed environments. Now, what that means is that you're able to handle large data sets, and the this Apache Spark engine, what it does is it creates an efficient way to execute queries on your very large data sets, right? So the .NET for Apache Spark component, what it does is it builds upon the Apache Spark engine, as you can see here. Let me zoom in just a little bit because it might be a little hard to see. There's the core component, and then there's the interop layer. So .NET for Apache Spark sits on top of all those things, being able to essentially let you use, very much like ML.NET, let you use the languages and the tools that you know and love to develop these types of applications, right? So that's just a gist of what these things are. And actually, they work quite nicely together, because if you look at the workflow for machine learning and data science projects, it typically starts with trying to solve some problem. You get some data, and you need to prepare this data to get it into a stage that is good enough to train a machine learning model, which once you get a good enough machine learning model, you then go ahead and deploy that and start using it to solve the problem that you originally identified.
Yeah. So I know a lot of folks have heard about Apache Spark probably in passing, and I'm seeing some folks in the chat here that are asking about it. Mm-hmm. So would you say Apache Spark really is something to ingest a lot of data and kind of clean it and transform it, or does it not matter how much data I have? Can it just be used with any type of data, like files and streaming things and whatever?
Yes, the answer is yes to all those.
Okay.
So you can certainly, that's the really nice thing about Apache Spark, is that you can use a lot of different data formats. So you can have your data in a database, you can have it in flat files, so CSVs, text files, whatever it may be. There's this other file formats like Parquet that you can also load into .NET for Apache Spark. So really, it doesn't care too much about the data. As you're able to work with a lot of different data types with Apache Spark. So that's one of the really nice benefits of it. Now, because it's intended to work in sort of a distributed manner, I don't necessarily have a graphic here, but the way that it works is typically you have this worker that's running, and then this worker, you're usually running Spark in some cluster, and the worker dispatches work and distributes the workload throughout the different sort of worker nodes, and it's able to sort of piecemeal process your data and apply the transformations that you define for your data in this distributed manner. That way it's designed to work in these for large data sets, right? So it's designed from the get-go to work on large data sets. Could you use it with small data? Absolutely, but to set up a cluster to work, that
would be a little bit of overhead, I guess.
It's a little bit of overkill. Yeah, exactly. But but yeah, you can certainly use it with any type of data, but typically it's with very, very large data sets. And speaking to the complexity of setting up one of these clusters, it's actually really easy. I see code with Sean here is asking if Apache Spark is different than Azure Synapse Analytics. No, so Synapse Analytics, and it's a bit difficult to explain Synapse Analytics because it has so many components, which is really interesting. But one of those components with Azure Synapse Analytics is the ability for you to build Spark pools, right, or build these Spark clusters that you can run Spark jobs on top of. And Azure Synapse Analytics sort of serves as that sort of layer that you interact with these Spark layers or with these Spark clusters, right? So Apache Spark is part of Azure Synapse Analytics, or Azure Synapse Analytics has Spark offerings to be able to execute Spark workloads. So they're not different in the sense that Apache Spark works with Synapse Analytics.
Got it. So Synapse Analytics has Apache Spark stuff plus other things inside of it.
Exactly. Yeah. Like there's so in addition to working with Apache Spark, you also have the option of working with, for example, SQL pools, right? So you set up these clusters of SQL databases that you can work off of. So it's really your choice. And I'm not quite sure how it works, but like I said, with Apache Spark, you could load data that is in a SQL database. So it's just a matter of what your workload looks like.
So then, and I know this is where we were planning to go, but now I'm curious now. So how does that now compare to something like Azure Data Lake? Because again, we have all these different data things inside of Azure, and I'm sure a lot of folks are like, which one am I supposed to use? So where does Data Lake kind of fit in that? That category of I have data I need to ingest and transform.
Yeah, so if I understand correctly, with Data Lake, it's just a place to sort of store your data, right? Whereas Azure Synapse Analytics provides you with the computing resources to be able to process that data. Yeah, so that's my understanding. And if there's folks in the chat that would know more specifically, feel free to correct me. But that's my understanding. So the Data Lake is just really where your data sits at rest, right? You dump all your data in there, but then you would use something like Synapse Analytics, perhaps using Apache Spark clusters or Apache Spark pools to process that data.
Got it. Okay, that makes sense. Okay. And now, as I'm looking at this diagram that you're showing on the screen right now, I could see, like you mentioned, there's that Apache Spark core, there's a Java Scala API, because I'm guessing like if the core of this thing was built using Java or Scala or some JVM derivative language. So now, essentially, what we have as .NET developers is .NET for Apache Spark, which is like an interoperability layer for talking to some of those APIs so that we could make use of some of that Spark functionality inside of the apps we want to build.
Yeah, exactly. That's exactly right. So it's really just .NET bindings. And actually, I think that this came out of, there was an older project called Mobius, which was .NET bindings. So I think that was sort of the predecessor to .NET for Apache Spark. But now you have .NET Apache Spark, which is built on .NET Standard and uses some of the more, I guess, newer .NET technologies.
Yeah, and I'm looking back here in the chat really quick, kind of going back to what we were talking about with Azure Data Lake. And Sean has a comment that said, I literally just had a conversation about Data Lake with someone. He told me that Azure Data Lake is for non-structured data, like files to be stored for use by SQL Server, Synapse, etc. So kind of like, I guess that's like you said, like it's a storage engine, right? Like we can put stuff in it, and then you could use something probably like Synapse to like ingest it.
Yep.
Yeah. Cool. All right, cool. So you talked to us a little about what Spark is. We know what ML.NET is. Obviously we spoke a little bit about F#. I'm really interested to see how these all kind of play together, because these are all three topics that I have no expertise in. So now I'm just going to sit back and let you wow me. It's like you kind of show me how these things play.
I'll definitely try. But let's take a look at some code. So let's see here. So what I'm taking a look at here is a .NET notebook, right? So this is using .NET Interactive for folks who are not familiar. And we kind of touched upon it in the intro here, which is essentially, think of it as these interactive programming environments that provide you with these really rich and visual elements, right, for running your code. So the scenario here, or the use case is, let me see if I can pull it up from the README here. But in New York City, for example,
there is the Department of Health, which performs inspections on restaurants and sort of, establishments that serve food. And essentially there we go. Essentially what they do is, they do inspections, and then, they'll give grades to the restaurant, where A is like, this place it's safe, it's healthy to eat at, you'll be okay, nothing's going to happen to you, all the way to, we should probably condemn this building, and
Right. You should probably not go there.
You shouldn't eat here, right? So this data sets come from there. And the reason why I like this data set is it's actually, number one, it's a real data set. So typically when you're trying to find data, a lot of folks will say, use the UCI repository, which is this archive from the University of California, Irvine, that has a lot of these sample data sets. And the really nice thing about that is that the data sets are super clean. They're great learning resources if you're looking to get started. You're also going to hear Kaggle, right? That's another really good place. But this data set, and actually this is not unique. So this is New York City Open Data Portal, but I believe Seattle has one. A lot of the major cities in the US, and I think even international sort of governments have these types of data sets. And you'll notice here that the data set was updated literally today. So you're getting real data. I think every night they do a dump of data. So you're literally working with real data here. So that's one of the really nice things that I like about that. So if we take a look at the data set, there's all these columns. So let me zoom in just a little. I think it might be a bit difficult to see.
Yeah, that'll be great.
But you get information about, this is sort of the ID of the establishment, the borough, right? So there's 5 different boroughs here in New York City. So that's information there. There's all sorts of address and contact information there, as well as information about the cuisine type. But what we're really interested in is these things here. So you have the violation code, and these are codes that, whenever there's a violation, they sort of, whoever is doing the inspection notes that down. There's this other sort of column here that's called critical. So critical is something that basically means like there's a risk of a foodborne illness. So for example, this 02G violation, that's a critical violation. And then despite having a critical violation, the grade of this establishment is still A. So so there's that grade that you typically see posted on sort of the doors of these establishments. And you have the score here, which the score is eventually used to provide a grade for these establishments. And then there's other stuff, right? So like the type of inspection that it was, location information about the latitude and longitude of where this place is, and all sorts of stuff. So using this data set, what we're going to try to do is we're going to try to process it with .NET for Apache Spark, and start to analyze it and see, like, where are most inspections done. Look at things like, the scores and the critical violations. But ultimately, what we want to do is, or the problem that we're trying to solve is, I assume that the city is backed up because there's thousands of restaurants in New York City. What we'd like to do is be able to provide them with a tool where if they enter the violations that they found during inspection, can we sort of predict what the score is going to be for that inspection, right? Or for that establishment's inspection. And that's going to be our goal. So we're going to use .NET for Apache Spark to process the data and analyze the data. And then we're going to use ML.NET to train a model that's going to take a lot of these columns as inputs and try to predict what the score is going to be for that inspection. So with that context, let me switch over to the code here to show you kind of how that looks like. So here in .NET Interactive, the first thing that I want to do is I want to get my packages. So because this is the data exploration phase, we're going to be using .NET for Apache Spark. And you can find that here at this Microsoft.Spark NuGet package, right? So if we were to run this cell, oh no. So this usually takes some time,
Sure.
So what this is going to do is it's going to go ahead and download the NuGet package. And the way that you do that, basically you're telling it, reference this NuGet package called Microsoft.Spark. And what that's going to do is it's going to go to NuGet and it's going to fetch all the NuGet package for you so that you can then use it inside of your application.
Right. And then kind of like you mentioned, you might have mentioned this a little bit before we got here, but so for folks that are just getting started with us, like if you download VS Code by default, like you're not going to have like this type of experience. You're going to need to install the .NET Interactive extension, the C# extension also, I believe. And obviously you'll have to have .NET installed, like the SDK installed on your machine. So those are like the 3 major pieces that you'll need. And so now whenever you head over to Luis's GitHub repo, and I'll share the link for that GitHub repo in a second.
Yeah.
Once you go into his GitHub repo and open it, then you'll be able to see like that experience that he's having here. But I just wanted to be clear because I know a lot of folks are like, hey, I opened a project and it doesn't look like this. Well, yeah, there's things that need to happen after that.
Totally. Yeah, no, thanks for pointing that out because, yeah, that's true. Yes, you don't get this out of the box. But yes, you're going to have to install this .NET Interactive Notebook extension, and that's going to give you this this notebook-like experience where you can run each of these commands sort of line by line, right? But in addition to just running the command, say, opposite to just running this in the console, you get this really rich visual output here. Okay, so it looks like that finished installing here. So the next thing that we're going to do is we're actually going to want to import it. So for folks who may not be familiar with F#, this is basically like your using statement. In F#, it's called open, and that's going to bring this package in. The next thing that we're going to do here is we're going to start a Spark session. Now, one step that I sort of missed here is typically the way that you submit jobs to Spark is with this Spark submit command. And with the Spark submit command, what it's going to do is it's going to start up the .NET for Apache Spark engine. It's going to submit, your code to this engine. It's going to execute, sort of optimize how it runs your code, and then it's going to execute it. In this case, though, you're going to notice that we add this debug flag at the end of this command here, and the reason for that is what this does is it starts the engine, but it doesn't submit anything. And instead, what it does is it just sits there in the background waiting for a connection. So when we initialize the Spark session here, that's exactly what we're doing. We're starting that connection, and we're initializing that connection with the Spark engine that's listening in the background.
Okay, so let's go back really quickly to that command line like you mentioned. So when you're starting that, you're starting the worker, right?
Yes.
In your submit.cmd. Is there like a centralized server or something like that, or can I? Because I'm guessing if I have multiple workers, they should all be coordinated with something. Is it like a centralized coordinator, or?
Yes, there is. There's like this. Yeah, exactly. There's this like main sort of node, right, that sort of dispatches it out via some scheduler, and that's a really nice thing about that. About Spark in general is that you're able to sort of, because it's all sort of open source and interoperable with a lot of tools. You can choose, what you use. Like for your scheduler, you can use something like Mesos, or you can use Kubernetes, whatever that scheduler is, to pass the messages back and forth between that sort of main node and your, at least with cluster environments, right? To pass those messages across between your main node and your workers, it's really flexible that way. In this case, though, I'm just running everything locally. So that's the other really nice thing, that before you even get started, you're thinking like, okay, I need to go set up some clusters. How do I configure the networking? I need to set up the IP addresses or whatever. You can just start playing around with it locally, right? And I think in the repo I included the docs where you can find instructions on how to set up .NET for Apache Spark and Spark in general locally on your machine.
Okay, got it. That makes sense.
Yeah. So in this case, so we initialize our session, and then what we're going to do is we're going to load our data into a data frame. Now, the data frame is exactly what it sounds like. It's a way to represent tabular data, right? So in this case, what we're doing is we're telling the Spark session that we want to read, perform a read operation. We're telling it that it has this file that we're going to read it from has a header, and one of the things that you could do is you can definitely be explicit and tell it what the schema of your data set is, and the schema is just the name of the column as well as the type. But in this case, I don't want to go through that process. I just want to tell it, guess, do your best, and try to guess what my data type is. Exactly. And then I'm just going to give it the path to where that data is, right? And the data is basically going to be the same thing that we saw in the Department of Health's website. That's the data set. So we're going to go ahead and load that data frame. And once that's loaded, we're going to go ahead and print the schema. Now, one of the things that I'll sort of mention is, and you're going to see that in a little bit, the way that Spark runs is it's lazy. So nothing actually happens until you sort of execute I think they call them action commands, right? So doing things like this, executing, trying to perform transformation or defining the transformations that are going to take place on your data, nothing actually happens. It's not until you call something like count right, or show and perform these actions that the data set actually instantiates in order to give you back that answer. So it's almost like you can think of it like an enumerable, right? Where an enumerable, it's just going to hold this reference to some data, but until you do something like toList or whatever, nothing's going to really happen until you do.
Right, no work has been done yet.
Exactly. So Spark works in a very similar manner. Okay, so that loaded, we're going to print the schema. You're going to see that it's exactly that same, the name of the columns and the data types are listed here. Now, what I want to do is I want to be able to see how many inspections have taken place broken down by borough. So in New York City, you have Queens, Brooklyn, Manhattan, Staten Island, right? So you have 5 different boroughs, and I want to be able to see what the count is. So how many inspections have taken place in each of these boroughs. So if we go ahead and do that, what that's going to do is it's going to execute this group by sort of a transformation, and it's going to perform an aggregation function to count, right? So, and it's going to store it back into a data frame. So there's boroughs, if we were to hover over that, let me see if I can get the IntelliSense happening here. Tooltips. There it is, right? So this boroughs, it's a data frame as well. So it performs the operation and it stores the result of that operation back into a data frame. So if we were to just take a look at what that boroughs data frame looks like, you're going to see that it's going to have all the boroughs listed along with an aggregate count of all those boroughs. Now, this is taking a little bit of time. Number one, because the data set it's a little bit large, but also because when you're streaming, it doesn't help.
Yeah. But I think one of the things that we could talk about while we're here is, well, what is a data frame? And I think for folks that are used to using notebooks in that Python space and using tools like Pandas and NumPy, like you might be familiar with what a data frame is. But for .NET developers, like what is a data frame in comparison to something kind of like you said, kind of like a list of things or just like a collection of things? Like why am I using the data frame and not just like an enumerable of stuff?
Right, exactly. Yeah, so what the data frame provides you with, a lot of times, it's not always the case, but typically what it does is it allows you to store things like, it allows you to store metadata about your data set, right? So one of the things is that schema, right? Like what are the column names? What are the types? But the other really nice thing that allows you to do is things like this, right? You're performing operations directly on your data set. So if you wanted to do something like this, let's say an IEnumerable, right? You could do it. You could do group bys on IEnumerables, but it would take a little bit more work. With data frames, a lot of times these transformations are sort of built into the data frames.
Right. Because as I'm looking at this right now, like that code looks like Link. Right. If you didn't tell me this was F# and you didn't tell me that was a data frame, I'd look at it and be like, oh, okay, he's writing a Link query.
Exactly.
But it's not a Link query, right? Like the implementation underneath it is doing something different so that we could, like you said, like work with large or small sets of data and be able to interact with them and kind of like explore them in a very efficient way.
Yeah, absolutely. Yep, you're exactly right. So like you said, right, for folks who are used to using Link, this is going to look very familiar. Now, the other thing that I'll point out is you're noticing here that I'm using the API. You also have the option of writing SQL queries. So if I wanted to write this as a SQL query, that's also an option. So you're able to turn these data frames essentially into views, like a SQL table view, and then you're able to perform and execute SQL queries using SQL syntax on it. The trade-off there, or at least one of the trade-offs that happens there is there's a reason why we have these tools and you don't necessarily write queries in a string when you're working with databases because it's not really type checked, and there's all sorts of issue when you just literally embed a string query into your applications, right? So personally, I would encourage folks to use this. The API itself, because again, it's doing the type checking for you and making sure that your queries are correct.
Okay.
Yeah. Okay, so we're gonna see here that here are all the boroughs, right? That looks okay, but then there's the 0 borough, which it's weird, right? Like that's not a borough, and it's
definitely not.
Yeah, there's not a lot of entries there, so I'd be okay just getting rid of it. I'm not even gonna try to investigate what it is. I just want to get rid of it. So that's exactly what I'm doing here, right? I'm just filtering and I'm telling it the borough column, get me everything that's not equal to 0. And that's all this is doing here. And I'm doing the same thing. I'm storing it in a data frame, and basically, actually, I do have to run this, but I'm not going to run the show command mainly because that's going to take a little bit of time. But you're going to get the idea that it's just going to remove this zero entry from here.
Right.
Now, what I'd like to do is I can kind of see this in this sort of console output like format here. But what I really like to do is I like to visualize this data. So in order to do that, I can use this package here, plotly.net. And what plotly.net is going to do is it's actually a .NET implementation of the plotly package. So for folks who are familiar with plotly, working with it in Python, working with it in JavaScript, right? This is exactly that, and it's actually the official sort of plotly implementation, because there was one before that called xplotly. But plotly.net, this one's sort of like, I believe it's funded and being worked on by the plotly team. So it's, yeah.
Got it. And then going back really quick, our friend Sean here has another question, and that was about like that query you ran previously. And he's asking, does it create a new result set, which is a copy of the data, or is it simply just filtering it out?
That's a really good question. I actually don't know the answer to that. I would imagine that Spark is smart enough, because so when these queries execute, they execute in memory, right? Mm-hmm. So I would imagine, especially if you're working with these large data sets, I would imagine that there's some way that it's not creating copies, and it's actually just finding ways to perform these transformations on the data without actually having to hold everything in memory. But I actually don't know, Kouashan, so I'll look into that. That's a really good question. I'm not exactly sure.
Yeah, my guess would be the same as yours, because I can imagine a notebook with multiples of queries, and if I have 20 queries, I don't want to have 20 copies of my data, because now my app is going to start running, so I'm going to start eating the resources out of the machine. So
exactly.
But yeah, it'll be definitely good to fact check that and see what's going on.
Yeah, for sure. Yeah, absolutely. Okay, so this installed already, and I just imported it into my package here. And what I'm doing here is I'm basically just selecting the columns that I'm going to need. I'm going to go ahead and order by, because I want to get the count in descending order. And what this collect operation is going to do is it's going to take the data frame and convert it into an IEnumerable. Then I can just use the pipe syntax or the pipe operator to basically perform additional processing on the IEnumerable, and this is just F# at this point. It's no longer Spark. And what I'm doing here is I'm basically just iterating through each of the rows, casting them, in this case, the burrows into strings, because the way that the collect function works is it basically just dumps everything as an object. It doesn't even try to parse like, okay, this column's a string. It doesn't necessarily maintain the schema that it originally defined. So we need to sort of tell as we're processing this data in this function here, we need to cast that object to a string for the burrow, and we're casting it to an integer for the count. And we're storing that result, we're performing a transformation to create a tuple, right? So let me see if I can run this here. Oh, I'm not using F# interact, but this is going to give you an IEnumerable. You're going to map over that enumerable. You're going to cast. So this row here, each of the rows, it's basically just it's an array, right? So we're accessing the first element in that array, casting it to a string. And we're casting the second element in that array, which is our count column, and we're casting that first into a string, which we then convert into an int. For whatever reason, I couldn't get this working to cast directly into an int. But these steps here are just casting, and what I'm doing here also is I'm creating a tuple out of it. I'm creating a tuple out of this. So I'm just casting and returning a tuple after performing this operation. And now that I have a tuple, I want to unzip it because I want separate lists. I want a list of data for burrows, and I want a list of data for counts. Let me just run this so that it's a little bit clearer to what's going on here.
Okay.
So once this runs, it's going to create a list containing the burrows column, the elements in the burrows column, and then a list of elements containing the counts column here. And then what I'm able to do at that point is I'm able to use this chart.column I'm able to use chart.column, which is using plotly.net. and passing in that boroughs and counts, lists to populate this this data set. Let me actually switch over because that interactive is taking a while.
Okay. And so one semi-unrelated question I wanted to ask you, because again, like I'm not extremely versed in F#. Is F# space sensitive, or is that is the way that you write it just based on your particular coding style?
Yeah, it is. So, and by space sensitive, do you mean like two spaces versus 4, or do you mean that there's no curly braces?
Well, from the perspective, they have to, the indentation has to match up, right? Like, so
Yeah,
for instance, if that line you had with sequence map was like a little bit over, like, would it not, collect the results from that previous statement?
I believe so, yes. I believe that if I were to run this, it would probably break.
Okay, let's not do that. But
yeah. So essentially, okay, so now I have the boroughs and I have the counts, and when I basically sort of visualize this, you can see that we get this really, really cool graphic here that we're able to sort of inspect here, and we're able to see that it's in descending order. Let's see here. Okay, so now what I want to do is, I know about this. I want to visualize where, I know that Manhattan has most of the restaurants, but I actually want to see this on a map. I want to plot this out. I can do that. So I can essentially create another data frame where I'm getting the latitude and the longitude, right, which were columns in our original data frame. Some of those coordinates are actually nulls, right, or they contain zeros, so we want to get rid of those. And then we do exactly that same thing. We collect that data frame, and then we map over it, perform some casting, and return a list of tuples. And then we run that unzip command again, right, to separate each of them elements in the tuple to its own list. So we can run that there. And then once that's done, hopefully it doesn't take too long, we can then run this point mapbox command. And what this is going to do is it's going to use mapbox, which I think these are like WebGL type maps. It's a sort of mapping engine that you're able to basically use for plotting data. So in this case, what's going to happen is it's going to take the labels, so it's going to provide the IDs for the establishments, and it's going to use the latitude and longitude to plot each of those points on the map.
Okay.
So,
and it looks like it's going to use OpenStreetMap. I guess that was it's saying on after the mapbox in it.
Yep, exactly. Yeah, that's exactly what it's going to do. So you're able to customize this. So I think the OpenStreetMap, I think it just pertains to the layers. I don't know if it's exactly using OpenStreetMap data, but I could be wrong. But it's
one of the questions I want to ask. Yeah, because one of the questions I want to ask is if I have an application that already has like a mapping thing, right? So, Microsoft, Google, Azure Maps, whatever the case is, OpenStreetMap, there's tons of open source ones. Can I use this and just layer on top of my existing map, or would I have to like use whatever support is inside of this library?
That's a good question. I'm not sure because this is actually new to I think this weekend is when they merged this change to use Mapbox. So it's like really nice. This is this is brand new. Yeah, it's nice. it's brand new. So I'm not quite sure. I haven't had a chance to look too much into the API, but I suspect that yes, you should be able to provide your own custom layers. Like for example, there's this other mapping solution inside of Plotly called Chloropleth Maps or GeoMaps. And with those GeoMaps, you're able to use GeoJSON and your own custom GeoJSON data to create your own map and display your own or render your own layers. So I'm not quite sure if Mapbox can do it, but certainly this sort of GeoMaps or GeoJSON type maps that you can use from Poly.net, you can certainly do that.
Yeah. Okay, that makes sense.
Yeah. And then if we were to take a look at that, you're going to see that. Actually, maybe yes, no. Okay, it doesn't want to. Oh, there we go. It's just taking a while. So what you're going to see now is it's going to display the map, and we were able to center it into this sort of New York City tri-state area. And after a while, we should be able to see is there should be a whole bunch of, there we go. There's a bunch of dots with the the latitude and longitude, as well as the ID of these establishments. So now you actually get to see a visual. I didn't go as far, but if you wanted to, you can create a density plot. So for example, let's say that I had the count of how many violations did the establishment have during the inspections. I'd be able to plot that and basically be able to visualize the severity of like, here's the place where like there's most violations, right? Maybe Manhattan, I don't know.
Violations.
Exactly. Right. So you can do stuff like that. But the idea here is just like, you can use .NET Interactive to provide you with these really rich visualizations and these visuals alongside, things like Plotly.net. And then you can use .NET for Apache Spark to go ahead and explore this data and process it and make transformations to it so that you're able to get a better understanding of what your data looks like. All right.
Right. Now we have a quick question that just pops in here from Twitch. And this person's asking, can you manually manage which frames are in the same context? And he says, I hate that you can have the same names in each frame, but when you call the frames in a weird order, it does different things. I'm guessing when he talks about frames, he's talking about the mapping frames, I'm guessing. I'm assuming he's talking about mapping frames and not data frames. I might be mistaken, but I'm assuming he's talking about the mapping frames.
Let's see, I hate how you can have the same names in each frame, but when you call the frames in a weird order, it does things differently. Yeah, I would. By frames, I think you might be meaning cells, right? So like, let's say that I had this point map box and I had it in here. Is that what you're referring to, Joshir? Like if I were to run this, would it run? And yes, like you don't necessarily have to like just have one line of code per cell. You can literally have like if you want, you can put your entire program into a whole cell, right? Like you don't have to do it cell by cell, but the benefit of doing a line of code per cell is you're literally able to evaluate it a line at a time, right? So I hope that answers your question, Joshir.
Yeah, and I'm looking at his comments in here, and he's saying, yes, by frame I mean one F# or one markup frames. Yes, that's what he's talking about.
Yeah. You could have the same, exactly. You could have the same concept. So if I were to have like let point map box twice, it's just going to output the latest expression that's in the cell, right? So that's how that would work.
Yeah, and it kind of like what Sean is saying here inside of the chat as well. The order does matter, right? So if you define a variable and then you, for whatever reason, decided to change the order or moved it around, now when you execute it, that variable will no longer be in scope, so to speak, right? Because you've moved where the thing was defined initially.
If you're still working inside of the same session, it would, because it sort of maintains the context of all these variables, right, or these values.
But then what happens if you go up and you run like a previous, like if you run a cell after, and then you again you'd moved it around, like now that data would have been wiped out, right? Because it's gone.
I believe so. Yes. Yeah. Let's see here. Okay. Yeah. So hopefully that answers the question. There. So
okay.
I'm going to switch over here.
How to do diagrams. We saw the maps, right?
Yes. So now we're actually going to get to this like actual queries. Like, okay, I did some exploration. I'm quite happy. I think I know which direction I want to go in. So I'm just going to switch on over to F# Interactive, which is it's this interactive programming environment for F# that's actually been around for a while. It's actually a really neat feature in F#, which basically just lets you write scripts, right? So instead of you having to compile an application, you can just start writing code directly in this FSX extension files, and you can just evaluate it very similar to how you would do it with .NET Interactive. The difference with F# Interactive is you don't get that visual component, right? So this is all, whatever you execute here, it's going to execute in the context of the console.
Yeah.
But for this case, I don't need visuals. I just need to be able to execute some command. Now this is a pretty chunky query here. So I'll run it, and then we'll see what happens. I think I might have to actually. Is it going to remember the context? That's a good question. This is actually trying it out live. So what I'm trying to do here is, because I have the Spark session already running, I wonder if I could continue that session now from my F# Interactive script. And I'm going to guess that the answer there is no, but yeah, there we go. So df is not defined. Okay, so I can't share that context. So let me go here and load the data frame. Spark session. Okay, never mind. I'm gonna have to run everything from scratch. So this essentially is exactly the same thing that we saw in the .NET Interactive data frame, right? But what's going to happen is it's going to go ahead and perform this query. Now, I know that we're running low on time, so let me just kind of walk you through it instead of running the code, because it seems that the code is taking a long time. I'm basically taking all of these columns from the entire data frame, and I'm performing a few operations on it. Number one, I'm getting rid of anything that has the date January 1st of 1900. Actually, in the specification of the data set, it tells you anything that has this date on it, it means that no inspection has happened, which I'm not interested in venues that haven't had inspections. I want to just take a look at the inspections. I want to take a look at any scores because that's the thing that I'm trying to predict, but I don't want any nulls. So I want only clean data. And of course, we want to get rid of those boroughs that have 0, right? Because we only want to take a look at the 5 boroughs. We want to perform a conversion here for critical flag, which basically this is a text column, and I want to change it into a number because machine learning models, they like numbers, they can't interpret text data. And then I'm just doing a group by where I'm going to try to get all of the individual inspections. So one of the things that I didn't mention is in the original data set, each row is its own violation. So it's not like each row does not represent an inspection. Each row represents a violation. So like, let's say that you had an inspection, right? If they found 3 violations, there'd be 3 rows for that one inspection. So what I'm trying to do is I'm trying to get all of the inspections that happen in the same time or during the same date for a particular establishment. I want to be able to basically group those together into a single inspection and say, all of these rows here pertain to the inspection that took place at this establishment at this date.
Okay, that makes sense.
And then I perform a few more other transformations. The way that this looks like, if we were to take a look at what the output is once I go ahead and save the results of running this query, is something like this. So here you have that ID, you have the borough, you have the inspection type, you have the score, and then this aggregation here, that's exactly what I did, right? So for this particular establishment, there were 3 violations that were found during that inspection. But then what I did here is I just grouped them into a single row, right? And then this one here is the number of critical violations. And this number here is how many total violations took place. So all of these columns here, I actually created myself. These were not originally part of the data set. It's just additional data that I was able to extract from the data set.
Right, okay.
Let's see here. So if I go over to machine learning, let's see, we got a long time. This is basically what my data input looks like, right? What I'm going to be using to train. I create an ML context to go ahead and basically initialize the context of my machine learning application. This is very similar to, say, like a Spark session or to DB context, right? In Entity Framework. It works the same way. It's just this way to encapsulate the context of an application. We're going to take a look at all the files here that are in this prep data directory. We're going to go ahead and load them. And then we're going to apply a few transformations. And again, all these transformations that are taking place, they're for the purpose of, as we saw in this data set, there's a lot of text data. And like I mentioned, machine learning models don't like or don't understand text data. So we need to be able to convert this data into numbers. So that's what these, like, I lost it here for a second. That's what these one-hot encoding essentially transforms are doing. They're basically taking the text data and converting it into numerical data. Right. And then I'm just applying this algorithm, and that's what I'm going to use to train. Once I have that set up, I'm going to go ahead and train my model. I'm going to evaluate it to see, does my model perform okay? I think when I trained this model originally, it did like 70%, which is good enough for our purposes. And yeah, here I'm testing it. So once this is done,
I want to ask you, because so one thing real quick I want to ask you, okay? When folks always talk about machine learning in general, ML.NET or otherwise, it's always about the algorithm, right? Like, what algorithm am I using? So in this case, did you use any of those model builder things that we spoke about a little bit earlier to kind of help generate that? Or did you just know what algorithm you wanted to use and you just kind of went to town on it?
No, that's a really good question. So in this case, because the problem is regression, I'm trying to predict the number. I knew that I was going to use one of the regression algorithms. But in the context of using automated machine learning and some of the tools that that MLNET provides you, I did not use any of those. I just randomly picked one. Ideally, though, I would actually just let AutoML do it for me, because AutoML can find the best model for my data set, right? I just need to provide it the data, and it's going to try to do try to find the best model for my data set. But in this case, I manually did everything. Yeah. So once you save this model, you're going to get this zip file here, which is just a serialized version of the model that contains information like what the model inputs are, what the model outputs are, which algorithm was used, and what transformations need to take place. Once you have this model, you can just embed it inside of a web application. In this case, we have this Saturn web API, which it only has a single endpoint, predict. And what that's going to do is it's going to take in JSON, an HTTP post request with a JSON body that looks like the model input here, right? So like this model input. So it's going to have these sort of these attributes, right, or these properties. That's what you're going to pass in, and then what you're going to get out is this data here, which is the inspection score is actually the actual one, because I'd like to be able to compare actual versus predicted. And then the score, that's the actual score, the predicted score. So let me just fire this up in the last few minutes that we have here.
Okay. And then looking at some of just, trying to understand some of the syntax that we're looking at, those items that are in the squared brackets and the greater than, less than signs, I'm guessing those are just sharp attributes, similar to sharp attributes?
Exactly. Yep. These are attributes, and these are just telling it, hey, this particular column, you're going to find it in the 0 index of that data, of that file. Yep, exactly. Yep. And then we need to make it CLI mutable, because data is data in F# is immutable by default. So by making it CLI mutable, we're telling it, hey, we want to be able to change the data, create an instance, and be able to change the data inside of that instance. So that's why we add the CLI mutable attribute up here. Once this decides to start, and I'll kind of show you here, because we might run out of time here. You're going to make an HTTP request, like I said, to that predict endpoint. You're going to pass it in this this body, right, in your request. And what you should get is a response that looks just like that. Now you can see here that the actual score for this data set or for this instance and this example was 11, and the model predicted that was 7. It's a little off, right? But then again, I actually didn't do a few things that I probably, if I had more time, that I probably would have done to try to optimize my model. One of those being that I could use the AutoML components to help me find a better model.
Yeah. Okay. I like how you're using Insomnia for this too. I know a lot of folks are like, what's that thing called? Postman, like, so this is pretty cool to see.
And Jashir, yes, you could deploy it. So this application here, it's literally just a .NET. Well, it's Saturn, but under Saturn, way down all the way is ASP.NET Core, right? So it's built on top of ASP.NET Core and Giraffe actually. So yes, you could deploy this to AWS Lambda. You could deploy it to wherever. Well, actually, Lambda is that's the serverless.
This is the serverless one.
Yeah. Okay. So yes, you can, because AWS Lambda supports .NET, and because you can just deploy these models to any sort of .NET application. The answer is yes. Not exactly in this format, but yes.
Sure. You package it up in some way that it'll be like Lambda consumable, I guess.
Exactly. Right. Yep.
Cool.
Yeah.
Cool. Well, Luis, this has been amazing, man.
Yeah. Yeah. No, it took way longer. When you're streaming, it actually takes up all your compute resources.
Yeah, it does. It does. I know for me, when I'm streaming Visual Studio, if we're using Visual Studio, it always takes extra long to like just build and run anything. So I completely get it. I'm sure our folks that are watching, they understand what it's like too. Do you have any, so like you said, we're running a little bit low on time, but do you have any final thoughts, words, resources, anything you want to share with folks before we take off?
Yeah, no, I mean, definitely give this a look. I think you pasted the link to the repo. So on your own time, I think I added some instructions there that kind of give you the walkthrough of what different components are inside of the repo and how you go about running them. So on your own time, I know I went super quick through this, but take a look, try it out, and if you have any questions, feel free to reach out on Twitter or wherever.
For sure. And like we mentioned a little bit earlier, all this month we're going to have tons of other things talking about F# and functional programming and these types of things. That being said, as you're going through this code, it kind of looks like C# to me. Like other than a few of the operators that look a little bit different, everything that you showed me so far, like the way that you call methods, the way that you initialize things, talking about working with tuples, and even some of those statements that kind of just look like link operations to me look very familiar, right? So as I'm reading your code, like I don't feel like I'm in an unfamiliar place. Like I'm not threatened or scared by like walking into this functional world, which I think is a great thing. So again, if folks are interested, like right here, take a look at the bottom. I'm showing the link to Luis's GitHub repo. Like you said before, if you want to reach out to him on social media, you could. He's always on Twitter. Luis, you also do the ML.NET community stand-up, I believe, right?
We do, yeah. We just had one on model explainability, so that was fun. We always have really fun guests come on. So yes, the machine learning community stand-up, .NET Doc show as well with you, and so stop by and say hi.
Awesome. All right, folks. Well, that's it for today. Thank you all so much for joining us, and we'll be back again next week. We'll have another special guest talking about some really cool things in the world of F#. I hope you all take care. Have a good day, and we'll see you all again. Bye, everybody.
Thanks.